Simple requirement HA. For some of the next slides, I'll compare a SQL 2008 R2 versus Denali implementation of this simple requirement. Let's see what it got. Requirement says it should allow automated failover, no single point of failure, zero data losses, primary, separate server for reporting needs, and a DR side with 5 minutes of data loss acceptable. So let's see how we do that in SQL Server 2008 R2. To define a quick and easy automated failover, we'll use a WSFC cluster with 2 nodes, active passive cluster, where shared storage is used. Though as the next requirement talks about that, we'll need to have an automated failover, which is covered here. Cluster is pretty good. Though in this scenario, there is a single point of failure as well, where shared storage, if it get corrupt or shared storage is down, then clustering does fail. And so now next requirement is to avoid the single point of failure, and in this scenario, as we know, shared storage is a possible single point of failure. And to avoid that, we'll install a secondary mirror, which would be like this, and based on synchronous, so that there is a zero data loss as well. So secondary mirror will have its own set of storage, which could be SAN or DAS storage, doesn't have to be any certified hardware. Secondary mirror can be used for reporting needs as well, though it allows only via snapshots, and snapshots does get stale. Application needs changes if to use the secondary mirror to achieve what they are looking for. And at the same time, to avoid the load on secondary mirror, we'll go ahead and configure a simple log shipping method, where this will serve as a reporting server and based on asynchronous data pass. This does provide, though, to manage the DR site failover of 5 minutes, we'll go to another site and create another log shipping with the minimum duration of 5 minutes. Ensure that the database logs are being processed and passed on to log shipping to site. So this is a pretty standard setup of HADR solution. Okay, let's look at the failure scenarios. If there is a issue on active node primary mirror, the clustering will take care of the automated failover and will go to the passive node, and passive node become active node. If there is a failure at shared storage level, in that case the clustering will be down, and all the links, all the jobs will be affected with that. The secondary mirror clients can directly not connect to secondary mirror. You have to do the manual failover to the secondary mirror to enable clients connect to it. And log shipping on both the sides has to be reconfigured with secondary mirror, or wait till primary node came up. So that's about how a typical 2008 R2 HADR solution would be in place. Now let's look at how always-on HADR solution with almost the same requirement helps. Does not need to have a cluster. The standalone SQL Server Denali instance would be just fine with the availability group concept. For first instance, for the safety sake, it's better to have it on SAN storage on a robust storage system which you want. Though it's not a requirement, you can have the local storage as well. And since you will have multiple copies of storage, it actually does not matter to keep it on SAN storage. SAN just provide you much better performance in terms of IOPS. To have no possible data loss, the SAN storage still provides, still comes with a single point of failure, and in this scenario, primary mirror is also a single point of failure at this point. So we'll go ahead and install SQL Server Denali on another box with normal storage, local storage, and then enable a WSFC cluster to add them both to the same node. So have a look at this. So this will not only provide you automated failover, We can use a file share witness. No need to have a shared storage between these two boxes. A file share witness will take care of the quorum voting of WSFC cluster. And so with asynchronous mode and automatic failure, it provides you a complete solution with no single point of failure. For reporting needs, secondary one can be used for it, but if requirement is to have a separate reporting server, you can configure another server which just need to be asynchronous and manual failover, since it doesn't have to have the data with for possible data loss. Now secondary 2 will have its own set of databases and own set of database copy. Okay, for DR side purposes, all you have to do is to configure another secondary with the name secondary 3 and set up a asynchronous mirror with manual failover that allows you less than 30 seconds of data loss, mostly based on the latency between the DR sites. And let's look at the failover scenario, how it works. You see the application using a virtual name to connect to the virtual name, which is right now on the primary mirror. If there is a failover will happen, virtual name will move automatically to secondary 1 since automatic failover is configured. And secondary 1 will be able to automatically establish its connection with secondary 2 and secondary 3 with the same configuration what was handled from primary mirror. So now all the secondary 2 and secondary 3 are continue to be in sync within minutes. Your primary side came up and the automatic failover will again resync with all the changes. In a normal scenario where the hardwares are identical with primary and secondary, you don't have to worry about doing the failover back from secondary 1 to primary. And that, let's have a look at how the client failover with the virtual name works. Okay, for this example, we'll use 3 SQL servers as a standalone nodes to see a particular scenario how the client failover works. QDC DB 21, 22, and 23. All these SQL servers are configured to have 2 databases configured with availability group called QDC AG. And the virtual name for that availability group is QDC vSQL, which application will use to connect. And a synchronous mirror is configured on both the nodes for this example. At this point, DB1, DB2 on 22 are the primary, and QDC AG and vSQL are residing on QDC DB1, DB2. QDC vSQL, the virtual name, sits on top of QDC availability group, and in this example, QDC availability group is made up of DB1 and DB2. Here, both the sides of the nodes are configured as synchronous nodes, synchronous mirroring, so no possible data loss is achieved as well. Let's see how application is connecting and can use the best use of this setup. So you have an app layer connecting to QDC vSQL and directly doing the write transactions on it. And here you can see the read transaction, it's using the QDC DB21 directly, doesn't use the virtual name to connect to SQL Server. So the purpose of the virtual name here is to use a database for the updates only. Now if there is a failover happen, let's see how the availability group and vSQL will behave. So you lose all the connections between that, automated failover will be executed, and finally the failover will happen, and QDC DB23 is where the vSQL and availability group will move. Application layer will retry and automatically get connection to QDC vSQL. QDC vSQL will be able to resync with QDC DB21 automatically once it is up, and everything will be in sync. Now at this point QDC DB22 is down, and but app layer is able to automatically connect and will continue to work. After a while your QDC DB22 will come back again, and QDC DB23 will be able to sync with that as well, and you'll backup have as it is. As you see in this process, the virtual name automatically flown and doesn't have to worry about the app to know that what is the failover partner, like in mirroring or something. No need to change anything at DNS layer. Everything will work as it is. So that's about it. And all these three nodes are running under a Windows Server failover cluster. The important part is these three are standalone in Denali instances. In the future videos, I will show you how this availability group to be configured, enabled, and the virtual name be used to test it out and have a app layer connected to the virtual name. It's just a default 3-node cluster. SQL Server instances are not clustered instances. Still, you get the benefit of having a virtual name, an automated failover, and as well as a particular availability group failover for a set of databases which you want to fail.